Good morning, my outstanding friends. This is going to be a bit of a shocker du jour on the not too good side. maybe not. I have been studying the tremors in the earth, the problems that are arising in the earth of volcanoes, earthquakes, all kinds of geological upheaval. You know, we all know about the global warming, and it is warming. Don't tell me it's just a natural thing. It is not natural, trust me. We have expanded the envelope of the earth so drastically from burning that the scrub in the outer atmosphere is causing huge turbulences and extreme scrub, tons of heat, which eventually get absorbed by the earth. They have no other place to go. They come down into our atmosphere, and yes, we sense it as global warming, but the earth eventually absorbs that warming. And as it does, anything that's in the earth that's biological begins to decay. As it decays, it swells. As it swells, it festers. And these are the source of volcanoes, earthquakes, tremors, instability. It's the swelling of the Earth's surface, literally swelling. And it's doing it in Alaska, it's doing it in a bunch of places. And we're going to go through that. And I don't know, but the Earth could literally explode. The Earth could literally explode under the conditions that we're seeing now. I don't have any other way to look at it other than to see what is actually physically happening and what is the actual possible outcome. Is it going to get cooler? No, it will not get cooler. It can't get cooler. That's not going to happen. Will it get hotter? Yes. When it gets hotter, what happens? Will it swell more? Obviously. Is there a breaking point? There might be. Is there a certain place on Earth that could trigger this catastrophe? And I believe there may be. Let's get into it. Okay, my friends, I've been doing a lot on volcanoes, Mount Spur specifically, but volcanoes in general, and they are getting devastating worldwide. And we may be in for an event that is unprecedented and could be extremely catastrophic. Okay, this adds a little more fuel to the fire, so to speak. Sulfur and carbon, a plight in the oil and gas industry. Well, what do you mean by that? This goes back to June 2023. Wondering how amine plants work. They're crucial for removing impurities like carbon dioxide, CO2, and hydrogen sulfide, which is sulfur and hydrogen. And they got to take that out of the natural gas, otherwise it's an industrial pollutant and damages the atmosphere and all kinds of things. Well, where's that sulfur coming from? I say the sulfur is because phosphorus is being forced up atomically and bumped up to sulfur because of the heat and pressure deep in the ground, which also creates the oils. But at the same time, it releases the membranes, which were the phosphorus, and crushes that and forces it to jump up to sulfur. Okay, my friends, microorganisms in Yellowstone steaming springs may reveal evolutionary adaptation. You wouldn't think anything would be able to live in that, but they are finding microorganisms. And this relates to the biology of the earth, not geology, biology. Okay, my friends, I'm going to give you some information that I received from my viewers. Steve Lindsay sent me this morning about the global unrest. Listen to this.
Volcanoes, fault earthquakes, rising magma. What's happening in the Mediterranean? It's something everyone's talking about. In these early months of the year, seismic and volcanic activity across the Mediterranean has sparked significant concern among experts and local populations. From Santorini to the Aeolian Islands, spanning Mount Etna and the Campi Flegrei, it seems the Earth refuses to stop trembling.
Okay, this is where we're going to get into some global situation of what's going on. Why is the Earth trembling? Why? I think I know why. And I don't know if there's anything we can do about it, but I think I do know why.
Fueling questions and theories about possible links between these events. The idea of an invisible thread connecting these volcanic areas is...
All right, when they say an invisible thread connecting the volcanic areas, they're talking about pretty much the equatorial regions. Now, the Earth, and in general, the entire Earth is heating up. The Arctic regions are thawing out. This is totally understood. The tundra is collapsing. The methane gases are escaping in huge quantities, and you only get methane gas from biological decomposition. So all the things that were frozen up there, they're biological. They're starting to decompose. They're gassing off. The Earth itself is literally expanding, and they know this. They say it's, I think I just saw almost 3 millimeters a month in some of these, equatorial regions. The Earth is literally expanding. Could it pop? I think it could. Okay, we got way up in Alaska, we got in Santorini, we got them everywhere. They're starting to pop. Mount Etna, Mount St. Helens is active. They're all, Yellowstone, quite active. They're all becoming active as the Earth warms up and the expansion occurs. And what it is expanding is like a balloon, and the balloon is starting to crack here and there, and balloons pop. All right, these are 3 recent ones I just did. Could Alaska sting the world with a volcanic eruption unequaled? Volcanoes, what do you think causes magma? What is the cause of magma? Mount Spur and the Aleutian chain might be set to explode. Well, it might be. And we're talking about the formation of the Earth, and basalt columns are not made from magma. There's a lot that we have to think about. Now, you see the white areas there? These are all areas of earthquakes and volcanism. We're going to look back into this briefly and then try to think about what are the possibilities that could occur from this. Are they just some kind of, little spectacular thing to look at and say, wow, look at that, isn't that cool? Well, there may be some long-lasting, and I mean long-lasting, results from this. Let's see what we can determine. All right, so as you know, I've been talking about volcanism and all kinds of earthquakes and all that stuff, and it relates a lot to the festering underground of biology, which creates oil. Now, I was looking into oil and oil deposits and where they are and how they form and all that kind of stuff. Well, Clinton Bosley here apparently works in the oil industry, and he got a hold of me and he said, well, here's what's going on, and they find radioactive elements in the salt water when they drill for the oil. And this was kind of new to me. So I started investigating it, and there is like a salt dome that covers this biology that's rotting underneath, causing these oils to form. And when they drill, they have to drill through the salt dome. Well, they don't have to do it. There's other places where it's not real that deep and that thick, but when they want the best oil, apparently, they have to go through that salt dome. When they get down into that area there, they got vast quantities of excellent grades of oil normally. They vary dependent upon where it was in the biology of the Earth, and I said yes, biology, because that is where it's forming. There was a catastrophe on Earth, and this adds another piece to the puzzle that I was missing. This salt layer is all over the ocean floor, in deep, everywhere on Earth, basically. It's 28,000 feet deep. And that apparently was the remnant of the impact of Venus to the Earth, creating this huge upwelling of salts and silicon and all this stuff as Venus almost hit Earth. Then all the creatures died, basically, and then the salt settled on top of them. This is what I was missing, because I live in the Triassic exposed area. I'm in one of the only places, well, there's a bunch of places, but this is where they actually, right down the street from me, is where they gauge the whole world evolution of the Earth and the dates based on the Triassic era, because I am in an exposed area, and all this stuff is Triassic, and it's right on the surface. I didn't even have to dig for this stuff, because I'm in the exposed area. And I mean, the meat and everything is actually flawless. So there was no salt dome over my region here. It's not under the salt. This is kind of poking up through the salt or something. And everywhere else on the Earth basically was covered in this salt dome. So when they go drill down for oil, they hit the salts. Now he's telling me, I'm going to read to you what he has to say about it. He says, I talked to one of the safety guys who said in Colorado, they actually find these radioactive elements, because when they get way deep, there's radioactive elements. And as they warm up, they expand. These radioactive elements also play a part in this. So he says, they're not only finding it low, but there is still traces of this, what they call norm, above ground that are strong enough to set off a Geiger counter. So they're coming, it's being pushed up so hard now that even the nuclear particles are coming to the surface. These radium and thorium and all that stuff. Now, they're hitting oil and salt at about 28,000 feet. That's in Colorado, I believe. But with it being as top present in other areas, the whole surface is probably showing it takes a long time for that to dissipate. Even the sunlight would probably make the surface hot. Whatever, the heat is being absorbed by the sunlight. Yes, absolutely. The whole Earth is being heated continuously. The Earth is supposed to absorb it. It can't absorb it anymore. We're heating it from inside. It's being heated from the outside. All the volcanoes are starting to erupt. The whole Earth is literally shaking and quaking, and what the outcome will be, I don't know. All right, I'm just going to show you a couple shots here. This is Mount Spur looking down into the caldera. And what I'm going to show you is this one right here was Etka, which is way down on the Aleutian chain. At the very tip of the Aleutian chain, well, not the very tip, but quite a ways down there. And then that exploded as I was working with the volcano people, Matt Haney specifically. I talked to him. I didn't talk to him. I tried to communicate to him. I didn't really get all that far. He did agree to talk to me, but when I sent him saying that it was biology, that all stopped. And these are all the active volcanoes right now. These are active volcanoes. All this, the Aleutian chain is ready to pop. It's just ready to pop. All that entire area. And these are all stratovolcanoes. These are point up, straight up in the air. Those are the ones that explode. Some of them just leak. Now, this is the volcano, the Aleutian chain. Mount Spur is up here. The whole thing comes down here, and that, I believe, could very well pop. Now, I'm just clipping in and out of my old video here. Now, this is the other one that's very interesting. These are all areas of seismic activity, meaning two different things. Seismic means they're shaking, and it also means they're likely a source of volcanism. And this is the Aleutian chain. That baby there is one gigantic volcano. That's not a whole batch of different volcanoes. This is one huge tube, one huge entire tube that is stratovolcanic, not just like something that would lay in like in Iceland, where it's just laying there and festering and flowing this way and that way. Same thing in Yellowstone, flowing this way and that way, but has a way for all of that pressure to be released. This is a different story. That is one gigantic balloon tube that is now warming up and festering with all extremely volatile chemicals. And as it does, there's nothing else for it to do except explode. Now, what will it just explode? A little pop, 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 maybe. Or will it go, pew, and once it starts to push all that other stuff, it's almost like nuclear expansion. Because this is going to be under such enormous boom. That's what happens in a nuclear bomb. Everything gets compressed, and then it spreads out so fast, it wipes everything out of the way. And if that happened, it would just continue down. It would be like one nuclear eruption in a row. Boom. That's a possibility. Nobody can discount that. The only people that they just don't look, they don't care. They don't realize it's biology, first of all. And I've shown it in just so many ways for 15 years now. And they just cannot accept reality. So you can walk around in a circle 1,000,000 times. It's not going to change the fact that that's biology. It's still biology. So walking around in a circle and hoping for the best is not a good strategy. Right? See, and the reason it's biology, it's Scorbzilla. I've shown it 1,000,000 times. This is his beard down at Crowley Lake. I've shown every bit of the detail about it, and I'll show you once again. All right, this is a shocker for anybody that hasn't been accustomed to this. Crowley Lake is right up there where all those white, big, huge tubes are, which is his beard. There's his head. And up around here, up in Oregon, my friend Tyson Carlson had done some fabulous work up here, and I'm going to show you some of the things he found, which are literally the biology and the skin of that creature. As it comes up here, Mount Spur is exactly where you'd expect it to be, because it's the rectum and it's a poop. And this is the digestive system, where Physics Girl was up in Fox, Alaska, in a cave that smelled like dog poop, because it's the digestive system of Spur, which is a rectum. And this is a cloaca, so it has, avian or reptilian plumbing, basically. And then this right here, that is just one gigantic volcano, one enormous volcano. It's continuously active. And Spur is a separate issue, because this is the digestive system. This here is the venom system. And there's the pincher. Now let me show you the biology. I have actual biology from Tyson. Now Tyson hasn't been active recently, but he did some fabulous work there, and I'll show you what he did. It's Tyson's Mud Fossil Adventures, and you can go up and look at some. He took on a whole new meaning of this one. Once you see this and it sort of shakes your world, I think maybe it shook his a little bit. Shook mine, I can tell you that. I don't know, it might shake yours too. Okay, so my good friend Tyson was doing research up here, and I think he's sort of withdrawn a little bit, and I can understand that. But what did he find? What did he find? He found that. Well, what is that? This is on the coast. This is membrane. That is a membrane from a creature that is the size of Scorbzilla. That is the upper layer of membrane. That's the lower layer. All right. Above that is just basically dragon skin or whatever he had for outer layer, feathers or whatever. Now, look at this carefully. You see all these little creases around here? You see that? You see that little blue thing coming up here? Another one over here? You see these holes? Nobody came up and broke those out. They were here originally, and they're all over. They're not just here and there. And people sit down in here and have campfires in here. That's how big these holes are. And all these are what I call a slurpee. If you've been around me, you understand what the slurpees are. They're small, leucine-rich proteins. It was like goo that covered this whole thing. And it could bend and flop and do all the things that your skin does and all that, but it would never open up to be penetrated. That's what a membrane does. It's a seal. The only places where things were allowed were here, and those were regulated by certain chemistry in the membrane. It only allows, it's called hydrophilic and hydrophobic. You don't have to know all that stuff. A membrane sort of is a separation layer, and there is also a fluid-filled highway in this area as well. And I'm going to show you that right now. But don't forget what you're seeing here. All those little seals. I'm going to show you what a membrane does look like. All right, there's a lot of little details that don't mean much to you specifically, but these are the slurpy layers around, and these are the tight junctions. And there's several different areas: a Huron junction, tight junction, then these desmones, and there's a gap junction down here, and then at the very bottom you have your basal lamina. Well, what does that mean? That's the skin. I mean the basement layer of skin, basically. And then below that, you have your flesh, which is your muscle and so forth. So above this is the skin, the really floppy skin, and it has all the little, well, let's take a look at what it does look like in its biological form. Now, if you want to know the chemistry, I have that too, which it shows you, whoops, this is, well, that's the animal soul. Let me go back this other way. I didn't know I had all that stuff in here. This is what I was going to show you, but I had another shot of it. Brain cell, universe. I didn't know all this was here. That's what's in a cell. That's a cell. All right, this is an animal cell. Mitochondria, that gives your energy. This here is the rough endoplasmic reticulum, which holds on to a ton of these ribosomes. Ribosomes are the little chemistry packages. We talked all about this. And you can have 1 million ribosomes, 1 million or more, inside of one single cell. And what do ribosomes do? They're chemistry sets. They don't do anything. They sit around waiting to be tickled. And as soon as you tickle them, they pop into a huge, elegant enzyme, and then it does the job it's supposed to do, just like that. You take one tiny ribosome, just one only is it called an enzyme, and you open that baby up, and it starts ripping through whatever it's supposed to rip through, and it does it millions of times a second, where that same reaction, if it took place naturally, would take years. These things are so elegant, but you have to have the right ribosomes. And the only way you get the right ribosomes is to have the right bacteria to squirt them out. And the bacteria is programmed to squirt them out exactly identical every single time. And if they're not squirted out correctly, they don't work. That's another issue. But every time I look back and see all these things I had, look at that, that's what's inside of cells. You know, it's they're showing an artist's rendition, but all right, cannabinoids, THC. No, what I was going to show you quickly here was this. These are the different cell membranes, and the reason is the phospholipids. See the P? That's the center of everything. Phospho. That's what makes you see phosphochlorine, phosphoglycerine. But they're all phosphorus, and they hang on to all these hydrocarbons. CH2, CH. Hydrocarbons are the things that when they start to warm up, they start to expand. That's why we're getting so much expansion inside the Earth. Not just outside, we're having terrible turmoils and hurricanes and tornadoes and floods and all kinds of devastation on the face of the Earth. It's coming out from underneath too. This is not a good situation, really, to be perfectly honest with you. All right, so don't forget, that is a 6 foot thick, or more than that, actually, of a membrane. And I think I showed you the membranes. This is this. These are the channels, or the big holes that are all over. The little blue spots I showed you are these, whatever they do. And the other part is these. You don't have to know any of this stuff. Just remember that there's 2 layers of phosphorus, and that's what creates your membrane. Now, it's loaded with hydrocarbons. This is just saturated with hydrocarbons. That's methane. Now, above this, or in this area, look, here's what it is right here. All right, you got your membrane. It's down in this area here. They really don't show it all that well, to be perfectly honest with you. Hold on a second. You know, this is probably the best we're going to do. This is skin, and there's literally hundreds and hundreds and hundreds of layers, which they don't really see, but they're showing them actually not too bad in this particular shot. Now, that's the skin, and that's all the skin layers, and they're meant to wear away. That's just what they do, and they just keep coming up. Now, that little layer there, they used to call it the stratum lucidum, and I guess it was considered to be, you could see through it. It was a little membrane. Well, now they realize it's a fluid-filled highway. And in addition to that fluid-filled highway, it is a membrane. So they're like together, one fluid-filled highway at the top, and then below that is the membrane. Now, below that is all the balls and straps in your skin, so that they're locked into position, but you can stretch them. They'll always come back to where they're anchored until you get older, and then they all get floppy. Now, this is your body proper down here. This is your muscle, organ, whatever is being protected by the membrane. Just think of it that way. So we have skin, wear away. It's meant to do that. Then we have a different story. It goes from the skin to the protective layer, which is the fluid-filled highway. From that fluid-filled highway, we go down into the membrane. In the membrane, you have all of your enzymes and your ribosomes and all that stuff. Bacteria is down in there. And it squirts it up into the fluid-filled highway to go and do where it has to do, wherever it has to go to do it. That's what it's really your immune system. And then below that, again, is all these balls that stretch and pull and do this and come back. And then you have the basement membrane, which is the basement layer of skin. Now I'm going to show you all these balls, and then I'm going to show you the basement layer in gigantic creatures. All right, these are all those balls. These are called the Moki marbles. They're out in Utah, Arizona, everywhere, because that was nothing more than skin as well. The whole entire earth is covered with these kind of gigantic things. And that turns into mud, which is the flesh. And then it all washes away. And the balls normally would have an edible surface around them, and moss and so forth would grow on it until there was nothing left except the hard stone ball, and that's the case here. Other cases, not that way. Up in Alaska, they're just starting to thaw out. These are the balls. Same thing, gigantic creatures. This is up in the Mount Spur area. It's just to the west, or to the east of Mount Spur, basically. And these are all those same balls. Only they've got moss on every single one of them, 100%. And that's because in the body of the creature, when it was alive, it had that same bacteria growing in there that it shows as moss here when it got in the sunlight. Now, we have the same sort of stuff in us. We have bacteria growing in us. Same thing, only ours is just so tiny and nobody ever even considers it. This is quite obvious. Every one of them has the same bacteria growing, and they're still meaty little meatballs. When they're done, they will just have that metal core in the center, because everything will be extracted out of it during the growing process. These have no roots, and they all sort of move. They travel together as a herd. And that is what they're doing, is they're traveling against or into the sunlight, whatever, away from the sunlight, into it, I would imagine into it. And they all sort of just drift together. And it's a total mystery to them up there in Alaska how this could possibly be. Until we get to realize that the Earth is biological and the creatures that were on the Earth, as Scorpzilla, and I'm going to show you the extreme details, there's just no denying it. None, zero. The only way you can do is just walk around in circles and say, it can't be, it just can't be, it just can't be, it just can't be. And that's what's happened. You see that? That's the basement layer right there. And these are all the balls have rolled off and turned, the fleshy stuff turned into mud. And this is not just the only place on Earth. And these balls are tiny compared to some of them. They're just absolutely enormous. You want to see this one? Look at this. This is over in the United Kingdom. These are the balls that are coming out of the wall as it washes in here and erodes. The skin, the interstitium, the membrane, the balls. Now, they're being eaten here. These aren't growing here. They say, oh, those are stromatolites. They just grow there. That's not true. These are being eaten by whatever the bacteria is here in moss in the saltwater flats in this particular area. Now, in other areas, they turn green, as I showed you up in Alaska, because it's in fresh water. Now, these balls are those balls. This floppy, gooey stuff is collagen, and it turns into the mud. It's your fleshy, muddy flesh, clay, basically. And the brown stuff is just a little tougher. You think of it this way: there's kaolin clay, kaolin clay, and that's a real soft flesh. And then there's a tougher flesh, which is bentonite. And I believe that between the two of them, you're seeing them here, and then you have the balls. So you got a flexible, real floppy skin, and especially on the face and all that area, there's a very, very floppy, thin skin, and it's they use it to make slip clay, to make fine china out of it. In other areas, you have the tougher, fleshy skin, still skin, and it still has the characteristics of skin, but it's just a little tougher. It's like a little more structural. That's all. But in between the bunch of them, the three of them here, they make up what ends up being this. The Moki marbles. Same thing here. All right, so let's just step back and take a good think about this. We got at least a 6-foot thick membrane going right into the ocean on the outside edge of Scorpzilla. So let's go back to Scorpzilla. Don't forget, 6 feet thick. In us, you could pick that up and look through it. Lucidium, you can look right through it. Now, on Google Earth, he's somewhere in Oregon. So I don't know, maybe up in this area somewhere. I'm not sure. Let's see where Oregon is. So here we are in Oregon. Well, he's out at the coast. So somewhere in this area is the skin of Scorpzilla's neck. That is a membrane. It's a membrane, and above that would have probably been the skin. And so here he is over there in Oregon. It comes all the way out. Don't forget, 6-foot thick membrane. It's got to be millions of times thicker than the membrane in us. Well, I don't know. Somebody could do the calculations. I'm not going to do it. Now, what do we have the rest of Scorpzilla? Well, everybody knows the stinger is way out here. And that is the tube. That's the little jabber here, the stinger. And that's the tube right there. And this whole line is 100% active volcanoes, the entire length of his stinger. And it comes back up to where Mount Spur is. Mount Spur is here. This is the digestive system. All right, Scorpzilla comes all the way up to here, and this is his guts. And he poops right out here, just exactly where you would expect him to poop. And then after that, in that gut area, it sucks off a whole batch of very toxic chemistry and brings it out to the pincher, to the stinger. All right, so here's spur right here. Right there, that's a cloaca. One side is the poop, the other side is the urine side. And right there is the pincher that pinches off the urine. You see the two of them? I call it a sphincter muscle. And that's the reabsorber of it. It's reabsorbing something out of the fluids, which is what happens in your body, on my body too. As you discharge things, different chemistry happens to reabsorb things that you don't want to have flushed out of your body. But they happen to be in that product that's moving through there, and then they just get reabsorbed. Now, this, to me, would be all where the guts are. And it is, because, like I said, physics girl was up here. She was in a cave. She said it smelled like dog poop in a very bad way. And then, over here, though, right after spur, you see all this chemistry, you see all these colors, you see all that? That is noxious, noxious, noxious times 10,000 million chemistry that's going to make up noxious, nasty venom that would shoot out through that noxious, nasty little pincher there to kill things, whatever it did. I don't know, but it's just a staggeringly strange world now that if you see it and you understand what you're looking at. And this thing is like, I think it was like 3 miles thick, maybe even more than that. And that right there, that whole line right there, is all the pincher juice. That's all pincher juice coming right out of here. Coming right out of the pincher juice factory. That's serious stuff. You see all these little chemicals going on here? That is manufacturing some noxious, nasty, toxic juices. Look at that. Every one of those is a different vile piece of chemistry as far as I'm concerned. You see that? And then it all pools together and it transitions out through this way. And every one of these is a volcano. They're all volcanoes. All volcano, the whole thing. And all of this is where the juice is starting to come down together, and then it comes through the tube, right down here. That's the tube. And it comes out right to the jabber. I know it's a crazy, hard thing for the human mind to put, to realize it's true, and it's true. And this is Mount Spur, just so you can see for sure. Big time in the news right now, because if something's going to happen there, one way or another. It's going to either be, Mount Spur pops because of the digestion here, or it's going to be that this pops because of the venom here. And there's just one of them went off right the other day as I was communicating with the volcano people up there, trying to explain to them, this is biology. I don't care how many times they walk around in a circle, it's not going to change that this is biology. So if they don't look, they will never know, and they will not look. As far as I can determine, they're not contacting me back. Originally, they agreed to talk, and that was it. As soon as you say, well, this is biology, well, the guy's a nutcase, just forget him. Just forget. And that's what happens. It just happened forever. I just showed you things that there's no way in the world you can deny. This is chemistry on steroids, and that puppy is going to pop one way or the other. It's either going to go as it warms up, or it's just going to go bada boom. And to me, this is one huge tube. This is not separate volcanoes. There are separate spots that have popped because they were a little thinner here, a little thinner there, more toxic here, less toxic there, more heat here, less heat there. Whatever the cause, they did pop here and there. They're popping along. But that doesn't mean the whole thing can't explode. And if the whole thing goes off, at that point, all bets are off. Because that would be a cataclysm of just staggering proportions. Would it shake the entire Earth? Would it cause other things to collapse and explode and who knows what? Could it cause a general calamity on our Earth? I can't discount that. And that's just one of them. They're happening everywhere. It's all over. It's everywhere, my friends. They called it the Ring of Fire. Well, the Ring of Fire has been heated up. It's a ring of biology is what it is. And that biology is rotting, expanding, spitting out methane gases, just gobs of them. It's actually shooting up radioactive material from deep down in the earth, which is supposed to stay down there. That's hot stuff. That is crushed particles, so crushed that they end up way at the upper end of the periodic table. All the periodic table means is this is tiny particles, bigger, 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 bigger. And there's certain sizes that they're not supposed to be on Earth. They're just too big. They don't stay together. They fall apart. They explode. They're radioactive. And those are the ones way up here. Radium, uranium, thorium, all. And they're actually being forced to the surface of the Earth now. And I'm finding this stuff out because I got friends that work in these industries, and they've seen these things. They just don't fully understand them because nobody can understand. It's all biology. Just like my friend here, Typhon. Now, I was doing some work on Typhon. He's another dragon, and so is Quetzalcoatl. Now, I found Typhon's heart. It's right there. There's the two sides of his heart. There's one side, that's the left ventricle wall, I believe, and this is the other side. You see the thickness of that wall? That's the muscle that at one time pumped blood through that thing. See? I believe that's it. These are the two sides of the heart. And they go in and go out through the tubes to deliver their contents. Look at that. If somebody, geologists can tell me that that's just natural, that's all, yeah, it's just normal. Oh, that stuff there, oh yeah, it happens all the time. And that's what they say, because it does. It doesn't mean it's not, that it's just a natural thing. It's natural, but it's not natural. It's not something that just happens because of its being geology. Once you get started to study on this stuff, there's no end. There's literally no end. And he wasn't read by the creature because here's where his throat got cut by Zeus with his great and mighty sword. The red is the artery blood, the black is the vein blood. They push each other apart. There are two polarities, but they're both iron, but one of them's got the O2 and one of them's the O3. And because of that, they will not mix. They actually create a little tiny membrane between them. You see it? He says, you stay on your side, I'll stay on my side. And the black turns very hard. Crispy, crumbly, you see it? And the red just stays fluid forever. But for some reason, the black here, this used to be green, so green it'd knock your eyeballs out. And the last time I saw it, there's one green spot left right there. This whole thing was just solid green, unbelievably green. And it was because of the blood flowing from the other side of the dam. Now, whether they just don't have any more blood, any more fluids to come through here, and this is all drying up and dying, I don't know. That I do not know. But this whole area here still has some green left to it. But it appears it doesn't have any more flow. And that's where that gash came straight across his throat. And that is his throat coming all the way up, all the way up, all the way up, all the way. And this is called the Dragon River, the Drach River. 1,100 miles long, the longest river in that area. Well, just keep going. And it ends up going up into here through the body of the creature. His tail runs all the way out here, from his head all the way out to his tail. These are more dragon scales. You see those? Obviously he's dragon. He's got dragon scales all over his body. Now, it takes a time to settle in, but you can see now, quite obviously, how. The hills and valleys don't make these colors and these patterns. You see the number of layers? And I have a dragon scale here. You see the number of layers on this one? The same thing. I don't know if you can see that. Very hard to see. But it has all those layers just like that. Let me see if you can see that. And then that would have been held right by that tab right there. And it's got blood coming from the bottom and some Slurpee and blood over here. Everything has to be fed with blood, and that's what this was fed with blood. And look at the colors and everything. Look at this. And what's leaking out here is literally blood. It looks like he got whacked here, and maybe with another hit from the great and mighty sword. But anyway, we have dismissed the reality of the world that we live in. And I don't know about this. I don't know what to say other than it is what it is. And now we just have to think about it, because as far as I'm concerned, this is very interesting and it's wonderful to understand this stuff, but is it meaningful to, let's say, your eternity? And I think it is, and I think in an extremely serious way. And until you can look and think and work with truth, you're just hoping for the best. And I am too. I don't have the answers to these things, but I have a lot of questions, and I have a lot of changes that change things the way they might have thought, or at least giving you new information, whether it's helpful or not helpful, whether it changes your beliefs or not, I don't know. That's up to you. But this has been dismissed and denied. And this has all been written. They said there will be false teachers and they won't let you know the truth. They'll hide the truth from you, and they have. And now the truth is open to everyone. But you have to start talking about it, you have to start thinking about it, or do whatever you want. To me, I'm not trying to push anybody into anything because I don't have the answers. I can't stand here and say, you do this, you do this, you do this, and then you're going to be fine. No, I don't know that. Nobody does. And I found there's people that they really, really, really have a serious opinion, and they just won't let go of it, and they will just violently try to push you into something. I don't try to push anybody into anything. I say, do you see what I see? Do you see what I see? I think you do. Most people do. Unless they just don't want to see it, and they're just not willing to examine the reality. But I'm going to tell you right now, the poles are thawing out, and as they do, like the Antarctica, blood falls, just gushing blood out of there. These things are going to rot, and the whole Earth is doing this. I don't think it's a good thing. All right, just think of this. The Earth as a ball gets a good blast over here. I mean, a hell of a blast, and they could be. What would it do to the rest of the Earth? It's going to react somehow. Could it go off its axis? I don't know. Could it sort of wobble like this and sort of shake and fluster, causing gigantic earthquakes everywhere else in the Earth, that wherever there's any bit of instability would be stressed? And you would certainly think that the oceans would bubble and fester and shake, and tidal waves and tsunamis and all kinds of things, if something catastrophic did happen. A pop here, a pop here, a pop there has never been an extreme issue. It's, locally, yeah, disaster. But for the whole world, no. I think this could be a different situation. We have expanded the envelope of our gases, so expanded that as we scrub through the universe, through the solar system, which is saturated with particles and fields, we are just extremely getting hotter and hotter and hotter. And as we keep burning things, the envelope just gets bigger and bigger, which means scrubber or scrubber, harder and harder. And you're going to probably say, well, space is a vacuum, there is no scrub. That's not correct in any means whatsoever. This is a hydroxyl radical, OH, a significant molecule found in space. It's everywhere, particularly interstellar and circumstellar regions, and is considered one of the most abundant molecules after molecular hydrogen, which is H2, and carbon monoxide. And then they're talking about the abundance of it, and it's found everywhere in space. Well, that is what we're scrubbing through. Okay, the reason the sun, corona way out here, is millions of degrees is the same reason. It's the scrub. This is spitting out particles, and they are spit out these electrons, which is light. This is a solar eclipse. The moon is on top of it, so you can't see the sun. All you're seeing is what radiates from the sun. So this is perfect to see. Now, way out here, it's millions of degrees, millions. On the sun's surface, it's only 10,000. And they can see this, they know this is a fact. And they can't figure out, why is it so hot out here? Well, it's fusion. No, it's not. It's the scrub of the particles trying to escape and being ripped through the other fields and gases in space. And you say, fields? What fields? I don't see any fields. Well, let me show you some fields. Plus, you see the red, and the red? That means the sun is actually spinning. And these are the impact zones that are much more impactful than the trailing edge. So it's spinning this way, moving that way, is my estimation, forcing big fields to collect at right in these three spots. They make their own little areas. And over here, this is trailing edge. So you don't see that extreme interaction, but here you do. So that's my opinion right now. Let me show you a little bit more on this. Just so you know, this is what's out in space. This was taken with a cell phone, with I don't know what kind of app he had on it, and I can't get through to the guy anymore. But this was several years ago. You could go out and try it. Take it at the night sky. I don't know what kind of apps they have on these things. But these are all the things that showed up. Every one of these glowy little things is some kind of particle in space, which is probably stars. And I know this is the moon. All of these are magnetic fields. That means that anything flowing through there, magnetic particles are light. Light is a magnetic particle. And as it flows through, it's going to be affected by that. Light does not travel at the same speed. It just does not do that. Light is a very variable speed thing. Now, this is what the real issue is here. The sun, 10,000 degrees. Out here, millions, because the sun is scrubbing through there, through all this stuff, which is not nothing. It's not a vacuum by any means whatsoever. I just showed you. It's scrubbing millions, 10,000. On the Earth, say 100-ish. Out here, what do you think that temperature is? What do you think that temperature is out of the ionosphere? That temperature is almost 3,000 degrees. Here's our atmosphere layers. Once you get past the scrub zone, this is the scrub zone. It's hotter than hell, 1,500 degrees Celsius. It destroys meteorites, burns things up when they come through there, because there's nothing but white particles here. And then what happens? How come it's so hot there? Out here it's not hot because it's very low density. There's almost nothing out there. It's very low, yes, but it's not empty by any means. And the fields are out there that they don't see. Fields are not dense with particles. They are fields. This is the scrub of the two fields of our planet against space. This is the hot zone. And then you come down below minus 80 degrees Celsius. That's 112 below zero. So you go from 1,500, which is like 2,500, let's say, above, to minus 100. You have like 2,600 degrees difference in that one layer, because this is a dipole. So this gets hot, this gets cold, this gets hot again, and that's where we are. And the Earth cannot accept it anymore. The Earth just cannot accept it. It's done. It can't accept any more of that heat. And everything's a dipole. So it's hot, cold. And the chunks of this gets hotter, that'll get colder. And that's exactly what's happening. The chunks of ice falling out of the sky now are just gigantic. The hotter this gets, the colder this gets. The colder this gets, the more condensed and the more ice forms out there. It's just big chunks and balls of ice, and they're going to start falling the size of refrigerators, possibly. The whole scenario here does not look good. There's some more stuff that's going right around us in space. This is not nothing. This is something, and this is something big. That's the moon. I understand the blue stripe too, which is compressed light. The moon must be going that way, forcing the light to compress as it is emitted from the moon. That's why you always only get just certain glow from the moon. There's just not enough impact against the moon. It's too soft, and the light that's hitting it bounces back as a radiation. It's just a soft surface. Well, if it's moving this way, that increases its impact into the light that's hitting it, and it turns blue. That's what we're seeing. The redshift, they think, is light pulling away from us. It's not. It's light slowing down as it comes through all these fields. This Webb's telescope is just nonsense. We have no idea where we are in the solar system or in the galaxy or anywhere, because everything is inconsistent. There's no homogeneous anything here, first of all, and there's absolutely no vacuum, and there's totally, unquestionably, no issue there. The fields. The fields are going to affect you. I don't care what happens. Fields drive particles or they slow particles down. I worked with that my whole life. I understand that so intimately. There's no question whatsoever. That is going to affect the light. That is zero question whatsoever. Okay, so what have I shown you? That scientists know nothing about the Earth and its surface and the interactions of biology and geology. It's basically the same thing. Now, and that changes our history totally, and our view on possible gods and who knows what, because that's what these things were. All that stuff was written about. Now, what else have I shown you? They don't know anything about space. There's no clue about why we're overheating, and then they don't know anything about light. Light is like a wave and a particle. There's a particle in there, and that particle has a big field surrounding it. And the field has to push everybody else's field out of the way. So you see a wave driven by a particle. That's pretty simple. And he can accelerate that by putting it through a venturi because it's virtually liquid. Light is a very fine liquid. It's a vapor. I call it atomic vapor. And as you shoot that light down through a venturi, it accelerates like crazy. And at the venturi, it explodes because light is made out of dark matter. Light is made out of dark matter and white matter. And that's why we've never seen the dark matter, because it's always encased by white matter, and the white matter bounces back. You see, you can never see inside. Every one of these particles that's here is made out of these particles right here, black ones and whites. All right, that's two Dirac neutrinos together. And that's a muon, the black one. The white one is the photon. All right, well, electron neutrino. This one's a muon neutrino. That's the electron neutrino. And between the two of them together, they make what's called a photon. We accelerated the light when it was not a photon. It was just a particle. A photon means it's literally bouncing back at you as a light particle. The reason we see it here is because of the reverse. It's hitting its own field. It's stacking up on its own self. So we see it as a photon way out here. Normally you wouldn't see that. It would have to hit something before it would actually create a photon. We can see it with the green too. Same thing, accelerated through. These are the neutrino phases before they turn into a full-fledged photon. And here's the photon. And this one's getting charged up as it moves forward, and the white one's going to flip to the back, and this white one will come to the front because it's got less energy, and this one's got all the energy. And that's what happens as they move through the fields that are in front of them. The one that's in front charges, the one that's in back discharges, and then it flips. See that? Light spins. Light doesn't flap like this. Light spins in a circle like this. Sometimes it goes way over here, sometimes it goes way over there. This is just like a drill bit. You can see it's spinning. All right? And this hits bang here, and then goes up and under and over here. It's just, and all of these little things are because the magnetism or the field from one particle to the next says, don't get next to me. He said, well, get out of my way. And they said, well, there's a guy on that side. We'll get him out of the way too. And they just boom, 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 boom. Perfectly, absolutely flawless little lines there. There is no other explanation for that other than that they don't want to be next to each other. And as they spin through there, they say, you stay your line, I'll stay mine. You stay yours, I'll stay mine. And we see this coming through the venturi because they are crushed together. And they hate that. They will not stay next to each other. They hate each other. And all of this in here is they're separated by just the tiniest little fiber. And they just don't want to be next to each other because their fields are pushing each other. It's called a Casimir effect. They'll push close enough, they'll never actually touch. They'll get to a certain distance and say, that's it, no more, done, case closed. And that's what we saw in that other shot. It's the Casimir effect. I'm going to leave it with this, but they're showing one time this big breakup of Gondwana, or whatever they called it back then. And the pre-salt layer was formed in restricted basins due to the breakup of Gondwana arid climates. Well, maybe. I don't necessarily buy that because I see everything as biology. Now, we're talking about the pre-salt layer, which means before the Great Flood. Before the Great Flood. Or actually happened in the Great Flood. The Great Flood is the salt layer that was when everything drowned and sunk to the bottom, and then the salt capped it off, and so it now is decomposing and creating the oils and gases. I think I've gone over that, but maybe not. The pre-salt layer is this area which changes all over the Earth. It's a series of geological formations on the continental shelves of extensional basins. That's right around where the continental shelves are the edges of the bodies of the creatures. All right, it's characterized by depositions of thick layers of evaporites, which salts, mostly salt. Some of the petroleum generated from sediments is in the pre-salt layer, has not migrated upward to the post-salt layer. The post-salt layer is after the flood, which is above it, due to salt domes. These domes were created above all the rotting creatures, especially common off the coasts of Africa and Brazil. Total pre-salt oil reserves are thought to be a significant fraction of the world's oil reserves. So these are pre-salt. They say a significant fraction. I say that's not true. According to Brazilian oil and gas companies, the oil and natural gas reserves lie below an approximately 2,000 meter, which is 6,600 foot thick layer of salt. So salt, that thick 6,600 feet of salt, which in turn is beneath more than 2,000 meters of post-salt sediments. So on top of all that was the fallout. So the salt traveled down, and then more stuff on top of that. That's the post-salt sediments. Now, which in turn is underwater depths of 2,000 to 3,000 meters. Because of this, drilling through the Rockies to extract pre-salt oil and gas is expensive. They have to go very deep to get to that oil, but it's capped off by the salt, which was after the Great Flood. All the creatures died. They're rotting underneath there, creating, festering, and decomposing into oils and gases, and they are capped by the salt. When they drill through it, it pops up salt water and actually radioactive water. And the radioactivity is because it's so deep in the earth that the molecules are crushed together, forming radioactive particles, which are way up in the top end of the periodic chart. They're just too big, and they don't stay together. They just explode and fall apart. That's what radioactivity is. They're not stable because they're just too big. And they're too big because they've just been too much crushed. And they just pop. And when they pop big chunks off. And if that hits you, it hurts you. All right, so what I've shown you basically is everything we've been told is in question, or absolutely no question about it, are not true. And walking around in circles hoping for the best is not going to get us anywhere. We need to have the Alaska volcano people look at that thing as a biological system. I don't know what they're going to do about it, but it would be nice to have some reality in our lives. And again, I understand the decomposition of the gases from phospholipids, which are the membranes of every creature, had the same membranes. They either bump up to sulfur, and you get the sulfurous fume or vapors from these boiling hot gases and fires that are inside the earth. The sulfur bumps up from phosphorus, or in the case of the flood, the phosphorus layers, which are the phospholipid membranes that coated bones and skin and organs and everything else, they came down to aluminum silicates, boiled down to that. And why did they do that? Because they flushed out all of their stuff and dropped down particles from phosphorus instead of bumping up, being crushed in heat. They dropped down, and they were being evaporated basically into aluminum silicates, and every single feldspar and almost every single rock there is coated with feldspar. Every single feldspar is an aluminum silicate. It has other inclusions, which could be minerals of other different sorts, but it's always aluminum silicates, and it's always from the Great Flood. It's a whole new world we live in, my friends, and to have our teachers not examine this for this many years is it's kind of hard to accept. All right, I love you all. Goodbye.